Moscow, 1938. As Stalin's purges tear through the Soviet Union, a brilliant young engineer sits in a cold prison cell, accused of being an enemy of the state. His crime? Building rockets. 2 decades later, this same man would become one of the most powerful figures in the space race, locked in a bitter rivalry that would shape the course of space exploration. This is the story of Valentin Glushko, the forgotten genius whose ambition fueled the Soviet space program and ultimately led to its greatest tragedies. Born in 1908 in the Russian Empire's city of Odessa, Valentin Petrovich Glushko was a child prodigy obsessed with the possibilities of space travel. At just 15 years old, he began corresponding with Konstantin Tsiolkovsky, the father of spaceflight theory. While other teenagers were still in school, Glushko was already publishing technical papers about space exploration. By age 20, he was working in the gas dynamics laboratory in Leningrad, designing some of the world's first liquid-fueled rocket engines. His early achievements were extraordinary. He developed electric rocket engines in the 1920s, decades before they became practical. And by the early 1930s, he was leading Soviet research into hypergolic propellants, fuels that would later power generations of rockets. But his meteoric rise was about to crash into the harsh reality of Stalin's Soviet Union. In 1938, at the height of Stalin's Great Purge, Glushko was arrested by the NKVD. The charges were absurd sabotage and counter-revolutionary activities. In reality, his arrest was part of a broader campaign targeting Soviet scientists and engineers. Glushko was sentenced to 8 years in a Shirashka, a special prison for scientists forced to continue their work while incarcerated. It was here that he met Sergei Korolev, another imprisoned rocket engineer. Together they worked on rocket technology for Soviet aircraft, forming a complex relationship that would later evolve into one of the most consequential rivalries in space history. After their release, both men were thrust into the heart of the Soviet missile program. But while Korolev became the face of Soviet space achievements, Glushko worked in the shadows, developing the engines that would power their rockets. The relationship between the two men deteriorated as they fought over technical approaches. Glushko favored hypergolic propellants, highly toxic but reliable fuels. Korolev wanted to use liquid oxygen and kerosene, safer but more challenging to handle. This technical disagreement would have far-reaching consequences for the Soviet space program. Despite their personal conflicts, Glushko's genius for rocket engine design was undeniable. His RD-107 and RD-108 engines powered the R-7 rocket that launched Sputnik 1 into orbit, shocking the world and starting the space race. These same engines in modified form still power Russian Soyuz rockets today, a testament to their brilliant design. But Glushko's most ambitious work came with the development of the RD-253 engine for the Proton rocket. Using highly toxic but efficient hypergolic propellants, these engines were masterpieces of engineering that could be stored indefinitely and ignite reliably in the vacuum of space. The Proton became one of the most successful heavy-lift rockets in history, with over 400 launches to its credit. Glushko also pioneered the use of staged combustion cycle engines, a complex but efficient design that would later influence rocket engineering worldwide. His innovations in pump design, cooling systems, and combustion chamber technology set new standards for rocket engine performance. After Korolev's death in 1966, Glushko's influence grew. He took control of the Soviet human spaceflight program and began work on what he hoped would be his masterpiece, the RD-170, the most powerful liquid-fueled rocket engine ever built. Despite his brilliant contributions, Glushko's legacy was overshadowed by several factors. His bitter rivalry with Korolev had split the Soviet space program into competing factions, hampering their ability to compete with NASA in the race to the moon. His insistence on using toxic hypergolic fuels, while technically sound, was seen as a crucial mistake that contributed to the Soviet Union's failure to develop a successful moon rocket. The N-1 rocket, intended to carry cosmonauts to the moon, failed catastrophically multiple times, partly because Glushko had refused to develop the large kerosene engines it needed. After Korolev's death, when Glushko finally had the chance to pursue his own vision for Soviet spaceflight, it was too late. The space race was effectively over, and the Soviet Union was beginning its long decline. His later projects, including the massive Energia rocket, were technically impressive but came too late to save the Soviet space program from budget cuts and changing political priorities. In the West, his story was largely unknown during his lifetime due to Soviet secrecy, and in the East, he was overshadowed by Korolev's legend as the chief designer. Today, Valentin Glushko's influence can be seen in rocket engines around the world. The staged combustion cycle he pioneered is used in the most advanced rocket engines, from the Space Shuttle's RS-25 to SpaceX's Raptor engines. His RD-180 engines, derived from his RD-170 design, powered America's Atlas V rockets for decades, an ironic twist of history that saw Cold War technology serving both sides. The Soyuz rockets that still carry astronauts to space use descendants of his original designs, making them the most reliable space launch system ever created. But perhaps Glushko's most important legacy is as a cautionary tale about the human side of technological advancement. His story shows how personal rivalries, political pressures, and technical disagreements can shape the course of history as much as engineering brilliance. In an age where private space companies compete to reach Mars, Glushko's experience reminds us that the greatest obstacles to space exploration are often not technical, but human. His journey from prisoner to space pioneer, from brilliant innovator to controversial figure, reflects the complex reality of scientific achievement in the modern world. As humanity stands on the brink of a new space age, Valentin Glushko's forgotten story has never been more relevant.